Hello everyone, Dr. Tausman here for you. We're going to be starting the lecture today. A lot of note-taking for today, not so much in the way of problems, probably until the end. We're going to be starting with talking about decision-making in statistics. Try to take good notes as we go along. I'm going to start with a simple example here. As many of you well know, the chances that if you're a woman that you're going to get breast cancer, that's about a 1 in 9 probability that something like that could happen. So in talking about decision making, I'm going to share with you kind of a sample scenario to kind of illustrate the different types of decisions that we can sometimes make if you're a radiologist and you're looking at a mammography result. So let's say that a mammography is done. The doctor looks at it, and let's just say it's in that realm of kind of ambiguous nature. It's kind of, there's some ambiguity about interpreting the result. So 4 possible situations might occur. One possible situation is what we call the decision. The decision might be that the doctor decides, yep, he looks at that mammography, yep, you have cancer. And in reality, you may have cancer. Now, if that happens, if the doctor looks at the mammography and says you do have cancer and you do, we would call that a hit in statistics. A hit is where you say something occurred and it did. So that's situation number 1. Situation number 2, let's say for the sake of reality, the doctor decided that, looked at the mammography and that you do have cancer. Wasn't really sure. It was kind of ambiguous. Looked at it and said you do have cancer. But let's say in reality that you didn't. The mammography was wrong or the interpretation was wrong. That would be considered an error. Can you see what kind of error I call that here? Yeah, that's called a false alarm. It's called a type 1 error. A false alarm is where you say somebody has a disease, but in fact, they don't. So that's a type 1 error. Another situation in terms of decision making might be that the doctor looks at the mammography and says, well, I'm looking at this thing and it's kind of showing, no, you don't have cancer. Well, let's say, just for the sake of example, that the person does have cancer. If the doctor makes this particular decision, you would call this, once again, another mistake. It's sometimes called a type 2 error or miss. A type 2 error or miss. Obviously, that's a bad situation to actually have occur. And then finally, the fourth and final situation is you look at the mammography. It says you interpret that mammography as seeing that there is no cancer. And in truth, there is no cancer. That's a correct no decision. So when you make decisions, in this case based on a mammography, based on some sort of data, you make a decision. It's what we call binary. It's either yes or no. Sometimes you might be right with that. That would be considered a correct decision, a hit, for example. Other times you make a decision and it's the wrong one. What we really like is, in this particular example, we want to make as many correct decisions as possible. We want to minimize these type 1 errors. We also want to kind of minimize the type 2 errors from occurring. And so that's often a tricky situation. What normally happens in this situation? Well, what normally happens in this situation is that if the results are ambiguous, well, you tell me. If the results are ambiguous, the woman would be asked to come back and have a biopsy done. Now, what does that do psychologically? Well, if they're asked to come back and they have to come back and do a biopsy, obviously that puts a little concern on the person's face, because just knowing that you're being asked to come back means it's not certain that you don't have cancer. So you're in that realm of ambiguity and you may be judged to have something. So that makes the person rather nervous. What's so much better about a biopsy? Well, a biopsy is going to basically cut down on the errors. It's going to give you what we call statistically, it's going to give you more power, more ability to figure out hits and make less false alarm and less type 2 mistakes. A biopsy has more what we call sensitivity. It'll detect whether or not you have cancer or not, whereas other tests like the mammography aren't nearly as sensitive to picking up differences. So obviously that's a little more scary, but at the same time it'll differentiate what is cancer and what is not. So if you want to take some notes on this, that would be appreciated. This was only about 5 minutes long, and I hope you understood it. We start easy like this, you can bet it's going to get a little complicated a little later. Thanks, bye-bye.